we're going to have a look at the basics behind the atomic structure. Now, this is something that you would have done back at GCSE, so hopefully this should just be kind of like a refresher for you. So an atom is made up of subatomic particles. There's three types of subatomic particles. There are protons, neutrons, and electrons. Okay, and in terms of where they are found in an atom, the center of an atom is called the nucleus, and the protons and the neutrons are found in that nucleus, and the electrons are found around the outside on something called an electron shell, and this is where you find the electrons. Okay, so that's what you should have done back from GCSE, so that should just be kind of recapping that. Protons and neutrons are in the center. Electrons are found, whizzing around on this electron shell. Okay. Focusing a bit more on protons, neutrons, and electrons, you need to know what their charges, or their relative charges and their relative masses are. So I'm just going to put mass here and charge here. Both protons and neutrons have a relative mass of 1, and electrons have a mass that is equivalent to 1 over 1835, but we say their mass is pretty much 0. Okay, it's a negligible mass, so we don't actually include that number in our calculations. We just say that the mass is 0. In terms of the charge, protons have a charge of +1, neutrons have no charge, and electrons have a charge of -1. Okay, so that's the kind of basics behind the atomic structure. What that then does is that will essentially tell us kind of the information that we need to know for this next part, and we're now going to have a look at the information that we get from the periodic table for each element. Okay, so I'm just going to go for lithium, so I'm literally just picking out lithium from the periodic table. With that, there are 2 numbers associated with it. You have essentially a bigger number and a smaller number. The bigger number is what we call our atomic mass, like so, and the smaller number is always the atomic number. Okay, these can be given different names. So atomic number, you'll sometimes hear people or me referring to it as the proton number. Okay, and that essentially is therefore telling us how many protons lithium has. Okay, so the atomic number or the proton number tells us that lithium has 3 protons. Okay, so within the center we have 3 protons, so I'm just going to draw 3 P's, and that's the number of protons it has. You should know if it has 3 protons and it's an atom, it therefore needs to have 3 electrons. Okay, the charges needs to cancel out, and therefore you need to have, I'm just going to draw over here, you need to also have 3 electrons whizzing around the outside. I'm just going to use E for now for electrons, and without kind of covering what kind of shells are, let's just put them all into the same shell. But you should know that that is incorrect, because you should have done electron configuration back at school, knowing that the first shell can only take 2 electrons. But just for the basics, we'll leave that there. And the atomic mass is going to tell us how many protons and neutrons we have. Okay, so the atomic mass is essentially the sum of the protons and the neutrons. We know it has 3 protons, and therefore the number of neutrons is just 7 take away 3, and therefore the number of neutrons is 4. So 4 neutrons and 3 protons in our nucleus, and 3 electrons found in the electron shell. Okay, so that is essentially how we can work out the number of protons, neutrons, and electrons for each element just by looking at the information given in the periodic table. If we then form ions, so if we lose an electron here, because remember ions are formed by the loss or gain of electrons, if we lose an electron here, the number of protons to number of electrons is now not the same. We have 3 protons but 2 electrons, and therefore we have an over. So if it's got +3 and only -2, overall the charge is +1, and therefore this lithium atom is now become an ion, and the ion has a charge of +1. Let's have a look at what an isotope is. So again, this is something you would have done back at school. Okay, they are atoms of the same element but with a different number of neutrons. Okay, so the only thing that changes here are the number of neutrons. Okay, therefore the number of protons and electrons stay the same, and the number of the atomic number stays the same, which it should do with each element, but the atomic mass is going to change. And the example that we're going to go through now is hydrogen. So hydrogen, as you know, has atomic mass and an atomic number of 1. So that tells us hydrogen here only has 1 proton and it has 1 electron. Okay, it doesn't have any neutrons because the mass number is 1. We have 1 proton, therefore it's just got 1 proton in its nucleus. Okay, now in terms of the other isotopes of hydrogen, there is this isotope. This isotope here is called deuterium. Okay, and as you can see, the mass number has changed, but the atomic number has stayed the same. So that tells us this is an isotope. We've gained so we've only got 1 proton, but we've got a atomic mass of 2. So that means we have 1 proton, 1 neutron, and 1 electron in deuterium. Okay, so the number of protons has changed. Everything else has stayed the same. We don't have any neutrons here, but we've gained a neutron here. And another isotope of hydrogen is called tritium, like so. And now again, the atomic mass has changed. So that tells us we have actually gained another neutron. So we now have 2 neutrons. Protons and electrons stay the same. Okay, so these are essentially the 3 isotopes of hydrogen. Deuterium is one that you come across in something called heavy water. And what it actually does is, or what these isotopes do, is they don't actually change the chemical reactions of hydrogen, okay? Because chemical reactions are all associated with the electrons, okay? Chemical reactions have nothing to do with the nucleus and therefore nothing to do with protons and neutrons. So as long as the number of electrons stay the same, the chemical reactions should also stay the same. Okay, so isotopes have no effect on the chemical reaction that occurs, but what it can do sometimes is change the physical properties of the element, or therefore of the compound. So for example, H2O containing this hydrogen over here is going to be less dense than water made with deuterium, which is called heavy water. Heavy water has a higher density compared to normal water. Okay, so it will change, or it can change some of the physical properties of the compound, but it can't change the kind of chemical reactions it will occur in.